to determine the domain of a function, we first want to determine what elements cannot be in the domain. And I do that here when I have a rational function. I do that by determining what elements would make the denominator be equal to 0. Because we do not want our denominator to be equal to 0. So x minus 3 cannot be equal to 0. That means x cannot be equal to 3. X plus 2 cannot be equal to 0. So x cannot be equal to negative 2. Now, we want to state this using interval notation. So all real numbers are perfectly fine except negative 2 and positive 3. So from negative infinity to negative 2, and I'm using parentheses around them to show that those are not included values, union negative 2 to 3, union 3 to infinity. And notice I used parentheses the entire way because negative 2 and positive 3 are not part of my domain, and negative infinity and positive infinity are not numbers. They are just the idea that our numbers can get smaller forever and bigger forever. Here, the domain of my function is when x plus 2 is greater than or equal to 0. The idea is we want our numbers underneath our radical to be 0 or greater, basically non-negative. So x has to be greater than or equal to negative 2 in order to make that happen. Now I use a square bracket to show that negative 2 is included, and then go on to infinity, because those numbers can keep getting bigger forever and ever and ever. When we are adding and subtracting functions, we're simply combining like terms. So for adding our functions, 3x squared plus 15x plus 2, and just combine my like terms. And then for subtracting, you may want to write out first your problem. 3x squared plus 7x minus 9 minus 8x plus 11. And then distribute your negative. 3x squared plus 7x minus 9 minus 8x minus 11. And then combine like terms. 3x squared minus x minus 20. And then for multiplying, we want to FOIL or use the box. I'm going to need a little bit of space to do that, so we'll start working this problem up here. We have 3x squared plus 7x minus 9 times 8x plus 11, and we want to FOIL. So 3x squared times 8x is 24x cubed. 3x squared times 11 is 33x squared. And then 7x times both terms in the second parentheses. So 7x times 8x is 56x squared plus 77x. And then negative 9 times everything in the second parentheses. So that's negative 72x minus 99. And then combine like terms. 24x cubed plus 89x squared plus 5x minus 99. And then dividing the two, we are just going to write them as a fraction. So 3x squared plus 7x minus 9 over 8x plus 11. For a composition of functions, it's just a function within another function. So in this case, we have g of h of x. So I'm going to take the h of x function and input it into the g of x function. So here 9x plus 5, wherever I have an x in my g of x function, I'm going to substitute 9x plus 5. So 7 times 9x plus 5 plus 2. 63x plus 35 plus 2, 63x plus 37. And then here, I actually have a number inputted into a function, and then that inputted into another function. So I'm going to start by figuring out what g of 3 is. Seven times 3 plus 2. So g of 3 is 23, and I'm going to take that result and input it into the h of x function. So 9 times 23 plus 5, and that is 212. And then finally, our application here, a company's profit is equal to revenue it generates minus the cost of producing and selling the product. And it gives me revenue, so we're going to come up with a profit function. P of n is equal to revenue minus cost, and cost is a binomial, so we're going to want to put it in parentheses. And we can actually distribute and combine like terms, and we get a profit function of 100 n minus 200. What's the profit if you sell 25 units? So I'm going to put 25 in for n. So P of 25 is going to be 2,500 minus 200, so $2,300. And then for part C, how many units need to be sold to break even? That would be a profit of 0. So 0 equals 100n minus 200. So 2 units need to be sold to break even.